In a town with no clean water, one man needs to be a hero.
We're gonna kidnap this guy, and he's gonna find us some water.
The thermohaline circulation, or Great Ocean Conveyor Belt, is an oceanic circulation driven by density differences in bodies of water throughout the ocean. The density is driven by thermo, or temperature, and haline, or salinity, giving the name thermohaline circulation. The water in the Atlantic, up here, cools and becomes more dense, and so it sinks beneath the less dense layers of water and forms the North Atlantic deep water, which essentially can be considered the start of the Great Ocean Conveyor Belt. This circulation, as it travels around the Earth, transfers both energy in the form of heat and matter as dissolved solids and gases around the globe. Because of this energy and nutrient transfer, the circulation can have a large impact on the Earth's global climate. Water is driven north by wind currents, and as it reaches the Arctic, it cools down and sinks as it becomes more dense. This cold, salty water then travels southwards to the Antarctic, where it picks up more cold, salty, nutrient-rich water, and it then splits into two different streams here into the Indian Pacific Ocean. As these currents move northwards, they warm up and rise to the surface, and then these warm surface waters circulate around the globe. And that concludes my lecture for today. Thank you all for listening. Yes, can I help you?
They swim to Greenland to melt the ice caps.
You can use the energy of the sun to melt the ice caps, and we'll collect the water in this bottle. It's working! It's working! Oh yeah? That'll do. I know you've got your water. Can I go home? You're alright.
But little did they know what would happen next.
And in breaking news, the Greenland ice sheet has been completely melted, with a hand lens being found at the scene of the crime. Leading climatologists are expecting an ice age to hit sometime between now and the day after yesterday.
Hey Doc, did you hear the news? Yeah. Well, what are we gonna do?
I can teach you everything you need to know. As I was telling you last year, before I was rudely kidnapped, the North Atlantic deep water is a major component of the thermohaline circulation. It is formed from a combination of warm saline Atlantic water moving northwards from the Gulf Stream, which then cools and sinks, and cool Arctic outflow from the Greenland, Norwegian, and Labrador seas. Approximately 12,000 years ago, the Earth saw a rapid change in climate known as the Younger Dryas. This was an abrupt period of cooling caused by the rapid melting and subsequent influx of glacial fresh cold water into the thermohaline circulation. This is thought to have shut down the thermohaline circulation, resulting in what is called an ice age by the stopping of transfer of heat around the globe. So what you've done is you've made the seawater more light. This can be achieved by precipitation, heating by the sun, river runoff, or what you did, melting icebergs. Now, in order to fix this, you need to make the seawater more heavy. This can be achieved by evaporation, cooling by air, or ice freezing and brine rejection, which is the addition of salt into the ocean as the water freezes.
So basically what you're saying is, if I add salt to the water, the circulation will start up again.
No, that's not what I'm saying. You can't fix this problem by yourself. This is a global problem. You're not just going to be able to go down to the ocean with a salt shaker and fix this.
Hold on. I've got an idea.
In a film some critics are describing as unbelievable, mind-blowing, and superb.
Wave goodbye, Ice Age.